Hi everyone, this is our 11th lecture in groups. So in this lecture, we are going to discuss about the cyclic group and its theorems. Let us have the definition of cyclic group. A group G is said to be cyclic if there exists an element A belongs to G such that every element of this group is of the form A power n. So here n is an integer. Then the element A is called the generator of G. Look at this definition. We are going to pick randomly any one of the element A. So A power n is generating all the elements in a particular group G, means we call it this A is generator of G. It is also read as G is cyclic group generated by A. Look at this example. We are going to consider a multiplicative group G is equal to 1 minus 1 I minus I. This is a cyclic group with the generator I. Since we are doing some continuous process for this generator, we are getting all the elements in that particular group, means we call it this element is a generator and this group is a cyclic group. Look at this. Here I is a generator, right? So now I square giving the value minus 1, I cube value is minus I, and I power 4 is equal to 1. Look at this group. We are going to pick one element I. So after doing some continuous process for this I, we are getting other elements in group G, no? So this is called the cyclic group. So it can be easily that minus I is also another generator of this particular group G, because minus I square value is plus 1 is in this group, and I cube minus I cube value is plus I, that is also in that particular group, and I power 4 is minus 1, that is also in group G. So I and minus I are the generator of this particular group G. So we are going to pick one element in a particular group G, and by using that, after doing some continuous process of that particular element, we are getting the other elements in that same group, means we call it that as generator. And let us move on to the theorems under cyclic groups. The first theorem. So any cyclic group is abelian. We are going to take one cyclic group. We are going to prove that particular group is abelian. So let us consider G be a cyclic group generated by A. Then we are written G is equal to A power n. A power n is the generator of this particular group, which means every element generated from this A power n, all the elements is equal to A power 1. That is the meaning of this particular statement. Let us consider two elements in G. These are equal to x is equal to A power m and y is equal to A power n. So after here A is a generator, after doing some continuous process, we are getting this x and y, no? So m is one integer and n is integer. We are replacing some value for A power, we will get x and y. Okay. So now we need to prove this group is abelian. So for that we need to prove x star y is equal to y star x. Now I'm going to take x star y at first. So x is equal to A power m and y is equal to A power n. So base is same. We can add the powers. So A power m plus n. We can also rewrite this as like A power n plus m. So now I'm going to split like A power m star A power m. A power n is nothing but we are taken that as y, and A power m is equal to x. So we proved x star y is equal to y star x. Hence the group G is abelian. So note, the converse is not true. Every cyclic group is abelian, but an abelian group is not a cyclic. Example, Q comma plus. This group is abelian group but not cyclic. Thank you.